Hello, everybody, and greetings from Vienna, and welcome to today's overview on what the DS lecture is going to be about. So, this week's DS lecture is basically going to focus a bit more on how we can do latency hiding, and we're going to see a number of paradigms. I call them the Magnificent Seven, a number of paradigms that further help us to reduce latency as much as possible. And we're also going to look at failure semantics in the sense that we're going to see what kind of fault tolerant systems can there be out there, in the sense that, for example, if you make a call on the server and it fails, can you make that call again without changing the state on the server? This, for example, is called an at least once semantics, because it allows your client to call your server as many times as it needs to. Some other failure semantics are not as lenient as this one, and they allow only for a particular type of applications, in which, for example, you can't or you're not allowed to make the same call to a server more than once. Another thing that we're going to talk about in this week's lecture is a very simple example of a fault tolerant, to some extent, protocol. And we're going to see how important it is in any distributed system that we build, how important it is for the client to identify itself to the server, for the server to know whether it has failed before, as well as for the server to know which client is calling its request, and also which method the client is calling. So, for example, a server needs to know whether, when it comes back again, whether it has crashed before. And the way it can do that is by maintaining a crash count. So let's say I'm a server, I have just come alive, I have a crash count of 0. If I crash, when I restart again, I'm going to increment this crash count to 1, and then I'll know, for example, that I've crashed, because I can compare with a previous value of this crash count that I've stored somewhere on the server, or on a stable storage. So if the server knows that it has recovered from a crash, then it can do certain operations, such as recovering the database from a permanent storage. And this might be very helpful, for example, for your assignment too. The same with a client. A client can and should identify itself to the server through an ID, and the session that the server, and the method that the client is calling should also be unique. Like this, the server, for example, is able to return the same answer to the client in case the response to a request is lost. So let's say I'm a client, I'm calling a server, I'm asking for a method, let's say in sum of 5 and 6. The server does the computation, which is 11, stores it on a local file, sends the response back to me as the client, but the response gets lost in the way. So what I can do now as a client, if I haven't received the response in a specific amount of time, is call the server back, identifying myself with my unique ID and the ID of the method that I've called, and the server then, instead of performing the computation again, can look at its stored value and return it to me. We're also going to look at a bit more complicated retry mechanism, which will help you again for the development of your assignment too. So latency hiding, failure semantics, and some fault tolerant mechanisms. All very interesting stuff. See you there.